Okay, Business Calc students, this is section 12.3, which is about the chain rule. And we're going to find the derivative first of some functions that are chain rule problems. So for this first problem, little review. If you have a function, which we'll call y, and it's equal to some function, which we'll call f of x, and that function is itself being operated on by some other function, which, for example, might be a power, or it might be some other kind of function, but for the beginning it'll be a power. Then we find y prime by first finding the derivative of what we call the outside function, which in this case was the power. So we'll bring the power down in front, keep what's inside the parentheses, reduce the power by 1. But then what's new with our chain rule is that whatever the inside function is, and again we're going to assume this is a power, we're going to need to take the derivative of that inside function, which is going to be f prime of x, and multiply it times the derivative of the outside function. So to begin with here, we will notice that our inside function is 8x to the 4th power minus 3x squared plus 3. And then we will also notice that our outside function is the power that raises whatever's inside the parentheses to the 4th power. And so in order to find y prime, first we'll take the derivative of the function that raises things to the 4th power, which means we bring the power of 4 down in front. We will keep what's inside the parentheses, and we will reduce the power, which is 4, by 1. And then the function that was inside the parentheses is, of course, still our 8x to the 4th minus 3x squared plus 3, and we are going to put that in the parentheses, but we're also going to need to multiply by the derivative of that function, and the derivative of that function is 4 times 8x to the 4 minus 3, minus 2 times 3x to the 2 minus 1, plus 0, because the constant of positive 3 is 0. And so again, what's still inside the parentheses is 8x to the 4th minus 3x squared plus 3. And so then that tells us that y prime, since we do need to do a little simplification here, is going to be 4 times 8x to the 4th minus 3x squared plus 3 raised to the third power times the quantity. 4 times 8 is 32. X to the third minus 2 times 3 is 6. X to the 2 minus 1 is x to the first, plus 0, which we don't need to write down. And at that point, we can stop. And since there's really no sense in multiplying that out any further, we're going to say that this, then, is our final answer. And once you get pretty good at the chain rule part of this and the power rule part of this, you really probably aren't even going to write that first step, and we'll go straight to the second step. But again, there's no real reason to go any further. The only thing that my math lab might do, which I don't necessarily recommend that you do, would be to take this 4 and to multiply it by both the terms in the parentheses at the end. But again, that's not really necessary. It actually just makes more work. And if we were going to substitute in a value for x, it actually would be simpler to substitute into this expression here rather than one that's multiplied out. So again, for our second function, we have 42 times the quantity 4t cubed minus 5, and that's all been raised to the 6/5 power. And so you need to remember that the 42 is simply a coefficient. It is just a multiplier, and all multipliers do, if they don't contain a variable, all a coefficient does is simply hitchhikes along with the rest. So we are looking for s prime of t, and the first thing I'm going to do is identify the inside and the outside function. And so the inside function is what's inside the parentheses, and then the outside part of the function is what's being done to that inside function, and that of course means it's simply being raised to the 6/5 power. And keep in mind, the 42, once again, is simply a coefficient. So s prime of t is going to be the derivative of the outside, which means you bring 6/5 down in front, you're going to keep that 42, because again it's just a coefficient, and then you're going to reduce that power of what's inside the function, parentheses, so that's going to be 4t cubed minus 5. And then the last part of this is we're going to take that power, 6/5, and we're going to subtract 1 from it. And then the last step is we're going to take the derivative of the inside function, which is 3 times 4 will be 12t squared, and the derivative of 5 is 0. So there's your first step. And then we have that s prime of t is equal to 6 times 42, and 6 times 42, 6 twos is 12, And if we carry the 1, 6 fours is 24, and 1 more is 25, over 5, no need to reduce that, times 4t to the third power minus 5, and then 6/5 minus 1 is 6/5 minus 5/5, which is 1/5, times the quantity 12t to the second power. And at this point, it's perfectly fine to stop and say you're finished. But again, if you do decide, or if for some reason you need to know that it's equivalent, then we can do one fairly simple step, which would be to multiply 252 times 12 over 5, times 4t to the third power minus 5 to the 1/5 power, and since that 252 times 5 over 12 is times t squared, we would also have a t squared here. So s prime of t is equal to, and here we'll use the calculator, and it's either 3024 t squared, because your t squared would stay in the numerator, divided by 5 times 4t to the third minus 5 to the 1/5 power, or if you would prefer to have a decimal, then that would be 604.8. So again, any of these answers is okay, but there's absolutely no reason that you have to go past that step to have done the calculus correctly. So our third problem is, again, similar, but not quite completely the same. Because in the third one, we realize that the thing that's in front of the parentheses isn't just a coefficient. Negative 5t, because it contains a variable, is actually the first factor. And 2t to the 8th minus 1, quantity raised to the 7th power, is actually your second factor. And that means we have a product rule. And because we have a product rule, we'll first deal with finding the derivative of factor 1. And the derivative of factor 1 of negative 5t is going to be negative 5. And the derivative of factor 2, which is our chain rule part of the problem, is going to be to take what's in the parentheses, bring the 7 down in front, reduce the power by 1 and make it 6, and then take what's inside the parentheses, which is 2t to the 8th power minus 1, and take its derivative, which is 8 times 2 is 16, t to the 7th power, and then the derivative of minus 1 is 0, so we won't write that down. And then, since we're going to have to do a lot of multiplying otherwise, we're actually going to take that 7 times that 16t to the 7th, and it's okay to use your calculator to do it in your head, but according to the calculator, 7 times 16 is 112. T to the 7th power times 2t to the 8th power minus 1, all raised to the 6th power. And now, in order to find m prime of t, we take the first factor, which is your negative 5t, and we multiply it by the derivative of the second factor, which is this, 112t to the 7th power times 2t to the 8th power minus 1 raised to the 6th power. And to that, we will add the second factor, which is 2t to the 8th minus 1 raised to the 7th, and multiply it times the derivative of the first factor, which is your negative 5. And then we'll do some cleaning up, but not nearly as much as my math lab would. So m prime of t is equal to, we're going to actually take the product of these first two. Negative 5 times 112 is negative 560. And t to the first times t to the 7 is t to the 8th. Times 2t raised to the 8th minus 1 raised to the 6th. And then plus negative 5, we're going to put the negative 5 in front, times 2t to the 8th minus 1 raised to the 7th power. Now, my math lab will go further than this. I will warn you. In my math lab, they will take this out one extra step, and I'm going to explain the step to you, but I don't expect you to do it. This is just for the folks that are actually doing the homework in my math lab and trying to come up with their answer. So what they would do in the next step is they would look at this factor of 2t to the 8th minus 1 and 2t to the 8th minus 1, and they would say, hey, the lowest power of that is to the 6th. So what they would do is they would actually factor out two t to the 8th minus 1 raised to the 6th power. And if you factor that out of your first term, what you have left is the negative 560 t to the 8th power. And if you factor it out of the second term, what you have left is negative 5 times 2t to the 8th minus 1 to the first power, because 6 times, or 6 added to 1 would give you that 7 back. And you wouldn't necessarily have to write that 1, but you would want to close the whole thing with parentheses. So this is equivalent but it is not absolutely necessary to go that far. And they would actually, to be honest with you, take it one step further. They would actually multiply this out and collect like terms. But again, I would not go to that much trouble. I have no problems at all with what I boxed in the yellow. I think that's a perfectly fine answer. That shows you know how to do the calculus. The rest is algebra gravy. Now, on this one, we have a hint. It says that this one is easier if you change it to a quotient. And you can do it as a product rule, but it is actually probably easier to do this one as a quotient rule because you have this power here that is negative. And so here we need to take the derivative of each one of the factors, or either the derivative of the numerator and the derivative of the denominator. So first thing I'm going to do is I'm going to make this into a quotient. So the quotient is that y is equal to 3x plus 5, which is your numerator, and then 2x plus 1, which is your denominator, and change that negative power to a positive power. So that if this is your numerator, then your derivative of your numerator is going to be equal to just 3, because it's the derivative of 3x plus 5. And then your denominator, which is a chain rule problem, is going to be 3 times what's in the parentheses to the second power times the derivative of what's in the parentheses, which is simply 2. So d prime is going to be 3 times 2 is 6 times 2x plus 1 to the second power. And then we will apply our quotient rule. And our quotient rule says we always start out with the denominator, which is 2x plus 1 raised to the third power. And we're going to multiply that times the derivative of the numerator, which is 3. And then subtract the numerator, 3x plus 5, times the derivative of the denominator, which is 6 times 2x plus 1 squared. And then we're going to put that over the denominator, 2x plus 1 cubed, but we're going to square that because it's denominator times derivative of the numerator minus numerator times derivative of the denominator over the denominator squared. So then y prime is going to be equal to 3 times 2x plus 1 cubed minus, and I'm going to take this 3x plus 5 times this 6 and call that 6 threes is 18x plus 5, just for the sake of not having too many parentheses, times 2x plus 1 squared, all divided by 2x plus 1 to the third power times the second power is going to make that 2 times 3, or 3 times 2, is 6. And once again, as far as I'm concerned, there is nothing wrong with leaving that answer exactly like that. My math lab, however, will go another step and will leave you with something that looks a little different. So just so that you understand why it does that, I will show you the next step, even though, again, this is not absolutely necessary. What they're going to do is they're going to look at 2x squared plus 1 raised to the second power is a common factor in the numerator. So they're going to factor out that 2x plus 1 squared. Which means that you're going to have, from the first term, you're going to be left with your 3 times 2x plus 1 minus 18x plus 5. And since we factored this out, that's going to be all there is left to that part. And then in the denominator, since there's also a factor of 2x plus 1 squared, they're going to change that into 2x plus 1 squared times 2x plus 1 to the fourth power, because here, when you're multiplying these two factors, you're going to add the exponents, unlike here, where you had the exponent raised to another power. This one, we're going to add the exponents. And so 6 is going to become 2 plus 4. And in this case, what happens is 2x plus 1 squared will cancel out. And so then what you're going to be left with is y prime equals 3 times 2 is 6x plus 3 times 1 is 3 minus 18x minus 5, all divided by 2x plus 1 to the fourth power, and 6x minus 18x is negative 12x, and 3 minus 5 is negative 2 over the quantity 2x plus 1 raised to the fourth power. And yes, you could go beyond that, but you wouldn't get anything that looks any simpler. So this would be closer to what my math lab might want. But again, there's nothing wrong with stopping here. I will not count off. You will receive full credit for stopping at that point. This is only for the benefit of the people that are trying to do my math lab homework and aren't understanding what the rest of the algebra is. So here we have a problem that looks really like a quotient rule, but honestly, I wouldn't try to do this problem as a quotient rule. Quotient rules are more complicated than product rules. What I would do is I would bring this denominator up to the numerator and write this as -3 times the quantity 3x plus 1 to the -4 power. And the reason I do that is because there's no variable here in your numerator, which means that its derivative is going to be 0. And if you start trying to do quotient rule with that, then you have a lot of things that disappear, and you wind up with something that actually looks a lot worse complicated than if we have a negative power. So we're going to find y prime by using the regular chain rule. It's not even a product rule. So y prime is going to be equal to, carry along your -3, it's just a coefficient. You're going to bring your power down in front, -4, times the quantity in the parentheses, and I left out the exponent there, so let me write it here, 3x to the 5th plus 1. And since that's a -4, we're going to reduce that by 4 and make that -5. And then we also need to multiply by the derivative of 3x to the 5th plus 1, which is 15x, plus 0 for the positive 1, and we won't write that down. And so we're one step away from our final answer. Y prime is equal to -3 times -4 is positive 12. And positive 12 times 15x, again, use your calculator, is 180. Times 3x to the 5th power plus 1 to the -5 power. Or if you'd like to turn that back into a positive exponent, although there's no need to, 180 over 3x to the 5th plus 1 to the +5 power, because you've moved it to the denominator. And either of those two answers is just fine. So then our next problem actually is a quotient rule, and we're kind of stuck. We're going to have to do it as a quotient rule. So this is going to be our numerator. And that means that our numerator has a derivative, which is a chain rule problem. And so n prime is going to be equal to, bring the 3 down in front, times 4t minus 3 to the 2nd power times the derivative of 4t minus 3 is 4. And since 3 times 4 is 12, that's going to be 12 times 4t minus 3 to the 2nd power. And then our denominator is 3t squared plus 5. So our denominator's derivative is going to be 6t. 3 times 2 to the t to the 2 minus 1, so that's 6t. And so then we'll proceed with our quotient rule. R prime of t is equal to, and remember, you're always going to lead off with your denominator and then eventually square it, so 3t squared plus 5 is going to get squared and left in the denominator. And then your numerator is going to start off with 3t squared plus 5 times the derivative of the numerator, which is 12 times 4t minus 3 squared, minus the numerator, 4t minus 3 to the third power, times the derivative of the denominator, which is 6t. Now, at that point, you've applied your quotient rule, and you've actually done the calculus at that point. But we will see if we can straighten this up just a little bit in case we need to use it for something else. So 3t to the fifth plus 5 times 12 would give us 3 12s is 36t squared, and 5 times 12 is 60, times 4t minus 3 to the second power minus 6t times 4t minus 3 to the third power divided by 3t squared plus 5 raised to the second power. And I'm sure my math lab does something ridiculous, like trying to factor out a bunch of stuff. And unless you can cancel something, factoring out a bunch of stuff really makes no sense. So we're going to quit there. So here we are at problem number 7, and it says find the equation of the tangent line to the graph of the given function at the given value of x. And the thing that I want you to remember is that when you're going to find the equation of the tangent line, what you're really going to be needing to do is you're going to try to find the equation of a line in the form y equals mx plus b, where m is the slope and b is the y-intercept. And your slope is actually related to the derivative of the function, which is f prime of x. And we could find the derivative of f prime of x, which is a chain rule problem, and involves fractional exponents. And I'll just tell you up front that the derivative of that chain rule is going to be 1/2 times x squared plus 55 to the negative 1/2 power times 2x, which is going to wind up being 1/2 times 2x is x times x squared plus 55 to the 1/2 power, or you can change it back to a radical. But I'm going to tell you right now that while this is a perfectly easy thing to do, in some cases it's not that easy to do, because what you really want to know is f prime of the quantity 3, because we want to know what the derivative of that function is at 3. And so I'm going to tell you right now the easiest way to find that is to use your inderiv on your calculator. So if you have the TI-83, you're going to use that function. If you have the TI-84, your function is going to look like that. And in either case, your answer is going to be 0.374999 9975. Now, in truth, that is not exactly what that is. You should realize that that's going to be 0.375, which is going to be equal to your slope. You need to round that off to a reasonable looking number. So your slope is going to be 0.375. Now, just in case someone notices this, that's actually the quantity 3/8. Which is what you would get if you actually use this formula and use square roots. So this is the proper slope, but I would have no objection to your using the decimal value for that slope, 0.0375, and that's actually what I would kind of advise you to do. So we now have the slope of that function. The other thing we need is we need the value of f of 3. Because we have an x value, we also need a y value. So in order to get f of 3, again, on your calculator, you're going to take the square root of 3 squared plus 55, and that turns out to be, since 9 plus 55 is 64, and the square root of 64 is 8, the y value is going to be 8. So that means that we also have the point 3, 8 for x, y. And so returning up here to our y equals mx plus b, that means that we have y, which is 8. We have a slope, which is 0.375. We have an x value, which is 3. And that's plus b. So it turns out that b is equal to 8 minus 0.375 times 3 which is 6.875. Or 55 over 8. And so now that we've gotten that far, we know that the equation of our line which is our tangent line, is y equals either 3 over 8 times x plus 55 over 8, or y equals 0.375 times x plus 6.875. And this is a perfectly acceptable answer. Decimals are okay. And this is a perfectly acceptable answer also. The key to remember here is that on these problems, once we're in chapter 12, especially on the test, when you're finding the slope, I want you to use n-deriv on your calculator for that value, not necessarily go through the trouble of finding the actual derivative. And now that we have that, then I want you to understand that I want you to, I want you to use the same process with this function, because you can imagine taking the derivative of this particular function is going to be a tedious process. And there's no need to do that when we can use n-deriv. And rather than write it all out, I'm going to say you're going to take the n-deriv of f of x with respect to x at the value 2, which means you're going to, on the TI-84, you're going to do d over dx of 2x parentheses x squared minus 4x plus 5 raised to the 8th power, which actually it'll give you an 8th power on that calculator that looks like the 8th power. With respect to, and that part of the symbol is from your calculator, you just hit your right arrow key after you finish your function, with respect to x equals, and you're going to type in the number, which is 2, for x equals 2. And so I'm going to take a moment and do that on the calculator. And my calculator says the derivative is 2.000016. which I'm going to take, since that's a numerical derivative, to mean that the slope and the derivative at x equals 2 is 2. Then I'm going to actually use the function and find f of 2. And I find that f of 2 equals 27. So that means my point is 2, 27. And since I have y equals mx plus b, that means that 27 equals 2 times 2 plus b, and since 2 times 2 is 4, 27 minus 4 is 23, is equal to b. And so my answer, the equation of the tangent line, is y equals 2 times x plus 23 for this problem. So again, use n-deriv to find your slope. Use your calculator to your best value. I have probably received more questions about this particular problem than any of the others. It says the total revenue from X stereos is given by R of X is equal to 4,000 times 1 minus X over 900, and that quantity is squared, and it wants us to find the marginal average revenue. And there's two things to look at here. The first one is that we're looking at marginal, and marginal always means derivative, but we're also looking at the average revenue. So we want the rate of change in the average revenue. And the average revenue is always written as R bar prime if you're talking about its derivative. What we have is the revenue function. We do not have the average revenue function. If you want to find the average revenue function, you always have to divide the revenue function by X, because it's how much total revenue by how many total sales that you had. And you can do this one of two ways. You can either divide everything by X, or you can multiply by 1 over X, whichever one is more convenient in the function. So in addition to it being the way that I stated it there, keep in mind that this could also be written, if it's more convenient, You can also take r of x, and in order to get the average, you can also take r of x and multiply it by 1 over x. And sometimes that's simpler. And in this case, it actually is going to be simpler to do that. So the first thing we're going to do is find the marginal revenue, R bar of x. I'm sorry, not the marginal, the average revenue. And I'm going to take this second approach, which means I'm going to take the revenue, which is 4,000, times the quantity, 1 minus x over 900 raised to the second power, and I'm going to multiply that times 1 over x, same as dividing by x. And then what I'm going to do is I'm going to multiply 4,000, which is a multiplier, times 1 over x, which is a multiplier. So R bar, the average revenue, is going to be equal to 4,000 divided by x times 1 minus x over 900, quantity squared. And then I'm going to actually try to write that in a way that's simpler for you to understand as well. So an equivalent form of R bar of x is again 4,000 over x. And remember, that's your first factor. And your second factor is 1 minus x over 900 is probably a little easier understood if you'll bring it out as 1 over 900 times x, so that you realize that 1 over 900 is just a coefficient and that's squared. So now that we have that, you should realize that we in fact have a product, and we need the derivative of our two pieces of our product. So the first factor is 4,000 over x, which we can also write as 4,000x to the minus 1 if we want to. And that means its derivative is negative 4,000 x to the minus 2. And you could leave it that way initially, or you can leave it that way all the way through. I'm going to use it that way all the way through. And then the derivative of the second factor is a chain rule problem, so we're going to bring the 2 down in front, keep what's in the parentheses. And when you subtract 2 from 1, I'm sorry, 1 from 2, you get just 1. So that's actually going to be more easily written as 2 times 1 is 2 minus 2 over 900 times x. And you can also, if you want to reduce that fraction and make your life easier, that could be written as 2 minus 1 over 450 times x. And then, of course, I also needed to multiply by the derivative of this, which is 0 minus 1 over 900. And the derivative of 1 over 900x is 1 over 900. And that, of course, is going to be multiplied by this whole thing. So eventually 1 over 900 times 2 is going to be 2 over 900. And 1 times 1 is 1. And 450 times 900 is $405,000, or 405,000 times X. And so here's my derivative of my second factor and my derivative of my first factor. And at this point, I should be ready to actually find R bar of X. So R bar prime of X, I have the derivative of a product. So that's going to be the first factor. Times the derivative of the second factor. Plus my second factor. Times the derivative of my first factor. And I'm going to change that to negative 4,000 over x squared, since I'm already dealing with some fractions anyway. So let's see if we can simplify that at all. 4,000 times 2 is 8,000x. Divided by 900. Minus 4,000x. Over 405,000. Plus negative 4,000 over x squared times 1 plus 1 over 900x. Quantity squared. And just a quick check. So this is change in the average revenue per stereo sold when X stereos are sold. And you could say dollars change, but it doesn't say that it's dollars or that it's not. So after a lot of work, this is the average revenue. This may or may not look like the exact same form as what I showed you in the answer key, because my answer key again comes actually from my math lab, so sometimes those answers are far more simplified than my answers. But if you have questions about any of these, please don't hesitate to ask, and I will try to present the solutions to the next two sections in the same way that I did these, so that if you need solutions, you have actual solutions, not just answers, but you also have explanation with those solutions. So I will see you when we finish the notes on chapter 12.4 and 12.5, which are exponential and logarithmic functions. Again, if you have questions, let me know.